In this question, we're asked to identify this red line here, what it is pointing to, and it goes from the minimum to the maximum. So the difference or the distance between the max and the min is the range. On this question, we're asked to match up these terms with the correct description down below. And it's using this example where a study was conducted in a local community to answer or to analyze which voters would be likely to vote and how on an upcoming bond. So taking from that example, these different aspects of it, what would we qualify them as here? So first, let's identify the difference between population and sample. A population is all of the members of whatever you're trying to study, whatever group of people, or it doesn't always have to be people, but if we use people as an example, the population would include every member of that community or whatever it is you're trying to study. Whereas the sample would be a subset of that larger population. So the population is all, and the sample is some. And so we can look down here and find the one that says all eligible voters in the community and know that that should be the population. And then we want to look for one that is a subgroup of that. So here we have a group of voters in the community. So it doesn't say all, it just says a group of them who voted, and this is randomly selected, right? So that would be a sample. So now that we've eliminated two of these or, accounted for two of these, it should be a little easier to move from here. We also see this parameter versus statistic, and this is similar to distinguishing between population and sample, because the parameter would be a measurement that comes from the population. So parameter, think metric, measurement. So it could be anything like counting how many, or counting a percentage, or calculating something else like an average, a mean, a median, anything like that would be considered a parameter if it's coming from the entire population. Similarly, a statistic is what you would call one of those things if it was coming from only a subgroup of the population. So now we're going to look for some sort of metric that refers to the population and a metric that refers to a subgroup of the population. So here we have the number of eligible voters in the study who actually plan to vote. And here also we see the number of eligible voters who actually plan to vote. So there's a very small difference between these two, but I know that each of those two, option A here and option C, are going to match up with either parameter or statistic because it says the number. This is a metric that is having to do with one of the two, either the population or the sample. So we just need to determine between these two options, A and C, which one is talking about coming from the sample, the number of voters in the sample, or which one is the number of voters in the population. So this one has this phrase in this study, answer A, and that implies that this is a subset of the population. It's only the voters that were in that study, not the entire population. Whereas answer C does not specify anything like that, so it is implied that we're talking about the entire population. So A would match up with statistic because it's only for the subset of people from the community that are in the study, while C will match up with parameter since it is about all of the people in that community or all of the voters. All right, so now we are down to just two terms that have not been assigned, and there's only two options left, of course, to match with those. So let's see which ones we haven't used yet. We used A, we did not use B. Okay, so B is one that could match up with data or variable. And let's see, we used C, D, E, and F is the other one that we did not use. So now we have the attendance of a single voter, and then F, voted, didn't vote, voted. Okay, so what are these two terms here? Data and variable. Okay, so it's important to realize that the variable is, you could think of a variable in different ways, but one way to think of it is it's a blank space where you're going to insert something, right? And so if you're making a survey, for instance, to go out and ask people to vote, you're going to walk up to each person with a blank space to fill with their answer. And to fill that space, you're going to ask a question that prompts a response, an answer. So the variable is the question that you would be asking the person. And the data is the actual answers that you get from asking this question. So the variable here would match up with the attendance of a single voter because you're looking at each eligible voter to see if they came and voted or not. And down here, this is where you actually get your answers and, you start collecting them into a data frame. So the variable is B, and oops, I did that wrong. I changed the wrong thing here. So what did I have here for statistic before? It was A, I believe. And so I meant to change the variable is answer B, and the data is answer F. Now this question is a great one that I'm sure some students had trouble with. There is a video attached, but I thought I would go through it again because I had a couple of students ask about it. And what we want to start with is just taking this data and typing it in to the spreadsheet. So you can copy and paste it, but the way it's given is not great for copying and pasting into cells. Like if you type it in with commas, what you want to do is type it into separate cells and just double check that you type these out nicely and don't make any errors with just that step. Then you're going to calculate the mean. Now to calculate the mean, it's very easy to do. You just use the average function in Excel, or you can add up all the numbers and divide by the total number of values. So now we have the mean finished, and we can copy and paste that right into here. And then we're going to start filling in this table. So notice that we are going to subtract x minus the mean. So this symbol here, x bar, is the sample mean symbol. So x minus the mean is what we want to do for each of our x values. And so we're just going to take the equal sign, then click on the first x value cell and minus the mean. To do this, you also want to make it an absolute reference where you have dollar signs in front of the column reference and the row reference of the means cell. If you don't, then you're going to have problems with your calculation. So make sure that you get those dollar signs in there, or you could just type the number in by hand. The only problem with typing the number in by hand is if it is something that it needs to be rounded and you round it too short, you could end up with round off error at the end. So using Excel to its full advantage, I recommend doing an absolute reference so that the x value here that's being used in the formula is is a relative reference, which means that when you drag this formula down, while this cell is referring to A2, this cell is referring to A3, and then the next one down is referring to A4, and so on. But all the while, as I go down, the mean cell that's being used is always the same. That's what we want. That's what we mean by an absolute reference. It doesn't shift. Once you have all your differences, you can copy and paste those into your table. And I just like to copy and paste because I don't like to run the risk of, typos or copying errors. So I take the time to go ahead and copy and paste them all. To me, it's just as fast and it may be faster and more accurate. Okay, then after I got that done, I want to now do the next step in the table, which says to square the quantities in this table. So we're going to just make that this right here, we'll call it the squares. You can put anything you want here that helps you remember what you're doing, but we're going to take each of the differences and raise it to the power of 2. And I only need that one simple calculation there, and now I have the answers to the table for the next part down. And then finally, we're almost to the point where we can finish this up. I just like letting you guys see me do this in real time. All right, now to get the total here, it's the total of the squared differences. So we're going to use the sum of these differences and copy and paste that right in. And now we're ready to actually calculate the standard deviation. So first of all, we're going to need the sample size n. So that is how many sample values you have. So we have 1, 2, 3, 4, 5 sample values. So the sample size n is 5. And that would mean that n minus 1 is 4, right? So if n minus 1 is 4, then to calculate the standard deviation, I'm going to be using this value, which is the sum of the squared differences, and this value, and I'm going to be dividing those and then take the square root, because the formula says to take the square root of the sum of x minus x bar quantity squared over n minus 1. And so this part is right here, and this part is right here. And so actually also interesting, might as well mention this, this part under here is actually the sample variance. So before you take the square root, that's the sample variance s squared. And then when you take the square root, it's the sample standard deviation s without a square. So now we'll go ahead and complete this, get the answer. The answer is the square root of 40.8. Oops, I need to start that over. Equals the square root of this cell divided by this cell, or you can just type in the number 4, however you want to do it. And there's your answer. And it says to round to 2 decimal places. And that's that. All right, now this question is actually super easy to do. Just copy the data and place into your Excel spreadsheet. And then you're going to want to use the built-in functions, the mean, the standard deviation, and the variance. And then you'll also want to do the population standard deviation. So these 3 are sample statistics. And then what we're going to do is see how the answer will be different if we are doing the standard deviation and we're doing it from an entire population, if we were to consider that this was the entire population. So it's just a little exercise to see how the answer can vary depending on if you are working from a sample or working from a population. So now we'll go ahead and calculate each one of those. So sample statistics, we want the mean, the standard deviation, and the variance. And then we're also going to want the population parameters, actually just one of them, the standard deviation from the population. All right, so the mean, we use the average function. Let me get in a little closer here for you. And you just double click it and enter. Then the standard deviation, you want the one that says .s, because as it says here, estimate standard deviation based on a sample. Double click, grab the values, press enter. The variance is simply taking the standard deviation and raising it to the second power. And the population standard deviation is the one that says STDEV.P, which calculates for the population. And that's the end of that question. Yes, it was really. All right, in this one, we're supposed to interpret the slope of the regression line. Now, first, can you identify the slope? So if you can remember y equals mx plus b in high school, the number that came right before the x or attached to the x was your slope, which represents rise over run, a steepness of increase or decrease. And so a negative 5x would mean that this is a line that's going downhill from left to right. And so we have a negative correlation, right? So it says a researcher wishes to examine the relationship between years of schooling completed and the numbers of pregnancies in young women. Her research discovers a linear relationship in the least squares line is given here, where x is the number of years of schooling completed and y is the number of pregnancies. The slope of the regression line can be interpreted in the following way. Okay, I think it helps to see this where we can write on it a bit. It's saying that we're letting x be the um, schooling and y is the number of pregnancies. So it's saying that there is a downward linear relationship of -5. So that means that from the y-intercept of 2 to get to another point and create a line, you would go, let's get a different color here. From here, you would go down 1, 2, 3, 4, 5, and then over to the right 1. So it's a pretty steep decline. And then you get this line here. Okay, so what you're seeing here is that as the number of years of schooling increases, okay, because the years of schooling are increasing to the right, right? So as schooling increases, I would say this, it appears that as schooling increases, what is happening as we move to the right, we're having to go lower to stay on the line, right? So as schooling is increasing, the number of pregnancies is decreasing. So the more you go to school, the less time you have for kids, I guess. It would be one way to interpret this. So it says a researcher wishes to examine the relationship between years of schooling completed and the number of pregnancies in young women. Her research discovers a linear relationship in the least squares line is y equals 2 minus 5x, where x is the number of years of schooling completed and y is the number of pregnancies. The slope of the regression line can be interpreted in the following way. When amount of school increases by 1 year, the number of pregnancies decreases by 2. No, that would be a -1/2. When the amount of schooling increases by 1 year, the number of pregnancies decreases by 5. Yes, that's the one. That's the one we just saw was happening. And if you want to just double check, when the amount of schooling increases 1 year, the number of pregnancies increases by 5. No, that would mean that you would have a left to right increase, and we don't see that here. And when amount of schooling increases by 1 year, the number of pregnancies increases. So any of them that say increase um, for both of the variables are definitely out because we had a negative slope, and slope is rise over run. So if you had both increases, then you would have to be going upward from left to right, not downward from left to right. All right, I think this question always gets a few students, even though we've gone over it and there is a video attached, it's somehow, oh, maybe there isn't a video attached to this exact version of it, but we've definitely gone over it. It's definitely in the playlist for test 1, but let's do it again. what we see here is that it's telling us to use the above scatter plot to decide whether the linear model fits the data well. Well, the dots look like they're fitting pretty close to the line, so I would say yes, just based on the scatter plot. Then the next part says to estimate the retail sales in the US in 2017 by billions of dollars. So knowing that we have a year and that the year is represented here is your t value, and t is year since 1995, what we're going to do is take the 2017 and find out how many years since 1995 that is. So you would really be just, you would be subtracting 2017 minus 1995, and that's going to be your t for this problem. Then you'll want to take the model they gave us here, 9.44t. Don't know if I can copy that here. It doesn't seem like it. 9.44t. So my sales would be equal to 9.44 times the t value, 22, plus the 84.182. Okay, so that's not too hard. And then it says to give it to the nearest billion, or it just says in billions of dollars. So I would probably put 292 there. Yes, okay. And then use the model to predict the year in which the sales will be 230 billion. So before they gave us the year and asked us to find the sales. Now they're giving us the sales and asking us to find the year. Okay, find t and then use that to find the actual year. So t is just the number of years since 1995, and then we want to actually convert that into a year. So the sales is 230 billion, and since everything is in billions of dollars, we're just going to use 230. Then to find t, we need to take that linear equation we were given before. Let's say y is sales, just to make it a little simpler, and t is the years, number of years. Okay, so we can take our linear model that we had here, and instead of using f of t, we can just write y. So we have 9.44t plus 84.182. And we're going to solve for t because t is what we're trying to find. So we're going to do inverse operations here. Subtract 84.182 from both sides. So then we have y minus 84.182. And then we're also going to want to divide both sides by 9.44 to leave t all by itself on the right. So now I can just plug in the 230 where the y is and get the number of years. Okay, so I'm going to do that here. I'm going to plug in equals then the quantity 230 minus 84.182 and then divided by 9.44. And then that is the number of years since 1995. So now I'm going to take 1995 and add the number of years to it. And then I see that I'm in 2010. And yes, there's some extra afterwards, but it's not a matter of rounding here. It's just that if we started out in 2010, if we have 15 years have gone by, not quite 16, so we're still in the middle of 2010. I hope that makes sense. You don't want to round up. Even if it was a larger number to the right, you would not round up here. You're still in the middle of that year. So we're going to go ahead and put in the answer as 2010. And there you go. It's not so bad. And we're going to match the given correlation coefficients on the right with the scatter plot on the left. So it's easiest, I think, to find the strongest looking linear pattern and match it with the strongest correlation coefficient. So the one that looks the most like a well-formed line is this one up here, where the lines dots are close to each other, and also they appear to be going somewhat like you could imagine drawing a line through here pretty well. And so I'm looking for a very strong correlation. So that means as far away from zero as possible. And since it's going downward from left to right, it should also be negative, just like the slope would be negative. The slope and the correlation coefficient are not the same value, but they do have the same sign. So yes, we should see a negative linear correlation coefficient here, and one that is as close, as far away from zero, or another way of saying that is as close to -1 as possible. So which of these is closest to -1? A is closest to -1. The next thing we can do is find the second most strong looking one, and that to me looks like this one down here, the third scatter plot. And it's uphill from left to right. I can see that pretty clearly. So I'm looking for one that is positive and the one that is the second farthest away from zero. Since we already found the one that was the most far away from zero, which was this one we've already used. What's the other one that's as far away from as the next farthest away from zero? Why is that so hard to say? So yeah, so it's positive as we want it to be, since this does look like an uphill trend from left to right. And it is pretty close to +1, which would mean perfect positive correlation if it was all the way to +1. So that's pretty strong right there. So this one's got to be C. Now the last two scatter plots don't look particularly much like a line. But I would say this one has the most random looking scatter of all. The dots are very far from each other. They're really just everywhere. And this one, they're a little closer together, and maybe you could kind of sort of draw a line that almost fits a good amount of the points. So, but it almost looks like there's several different lines you could argue might work here. You could draw one from here through here, maybe one, it almost looks like it would be a flat line. In any case, I would guess that this one, the second scatter plot, has the weakest correlation of all of them. Um, but they do look very close. Like we have -0.16 and +0.15. So in terms of strength, these last two unused options are so close to each other. One is negative and one is positive. So we just really want to look at the one that seems to be more slightly negative. And I'm looking at these going, this is not an easy decision, honestly. Um, Whenever these problems get regenerated, sometimes it's a lot more obvious than this one is. And I'm honestly feeling like I'm not sure I'm going to get this right. I'm going to guess that this one is negative. I'm not sure exactly why I think that, but I guess it just feels like the values are more decreasing from left to right, or the dots seem to be decreasing more from left to right. This one I feel like is slightly more positive. Of course, I am seeing a very, definite trend down here, but I don't know. I don't feel confident about this at all. So mm, let's go with, I'll go with my instinct. I'll say this one's the negative one, B, and this one's the positive one. Oh, I still don't know because the positive one is supposed to be slightly weaker, and I feel like this one is slightly stronger. Oh gosh. I'm going to change my answer. I'm going to go with -0.16 for this one. I'm going to go with B here and D for this one. Let's see if I'm right. I got them all right. Good job, me. As I said, they're not always so hard to tell. The last two, I can usually get that a lot more confidently. This particular version was a little hard.